researchers recorded that a certain bacteria population grew from 125 bacteria to 2,625 bacteria in 20 hours from the start of the experiment. At this rate of growth, how many bacteria will there be after 30 hours from the start of the experiment? So this is another question where they say at this rate of growth, but they don't actually tell you what the rate of growth is. So we don't know what K is, so this is going to be a two-step problem. So step one, we need to find K, and then step two, we need to use K to find A, and this will be after 30 hours. So I'm trying to find K, and I'm using the A0, and T from the known time frame. So we know that the population grew from 125 to 2,625 in 20 hours. So I don't know what K is, but I know my A is 2,625 and my A0 is 125 and my T is 20. So K is equal to ln of 2,625 over 125 all over 20. And we can try to reduce that fraction on the inside of the logarithm, and that reduces to 21. So K is equal to ln of 21 over 20. So part 2, we know what K is. Now we need to use it to find A after the 30 hours. So I know my A0 is 125 because that's what we started out with. And K is equal to ln of 21 all over 20. And T is equal to 30. So my formula is 125 times E, and we have a big exponent. It's ln of 21 over 20 times 30, and that's all in the exponent. So I need to type this out. And I get 12,029 bacteria. If you have the older version of the calculator, you'll have to type it in like this.